Okay. So, hello, my dear friends. Good afternoon, everyone. How are you all? Yes, absolutely. So, my dear friends, we had started our topic, the name of which was production. One class we had already done. As far as production is concerned, today is the last class. As far as production is concerned, today is the last class. So, my dear friends, before we start, let's summarize in the form of MCQ whatever we have studied in our last class. Okay. So, let's see. This is a 5 marks test also. Okay. Let's keep it 4 marks because 5th marks I will explain. Okay. I did not explain in the last class. All right. Law of variable proportion operates in short run, long run, medium run, all of the runs. So, my dear friends, the answer is obviously short run. Law of variable proportion operates in short run. In law of variable proportion, when TP is max, what is MP equal to? Yes, you people guessed it right. MP is equals to 0. That's right, friends. MP meets AP when which is max. Remember, MP meets AP when AP is maximum. MP meets AP when AP is maximum. Okay. Okay. When is MP at its maximum? When TP is maximum? No, because then MP is 0. When at point of inflection at both or at none? Yes, you people guessed it correct. That's a MP is maximum when you reach at point of inflection. So MP is maximum where? When you reach the point of inflection. That's right. Moving on. Now, why does stage 1 operate? This is the explanation part that we will have to discuss. Then I will come back to this one. Okay. This one I did not explain in the last class, so no use asking question. Okay. Now let's study the different stages. Explanation of the stages. You know, there are 3 stages we know: increasing returns, diminishing returns, and negative returns in the law of variable proportion. Today we are going to study why these stages operate. Like, what is the logic? What is the explanation behind the stages? Okay. So let's have a look at it. Let's have a look at it. Okay. So let's discuss reason behind each stage. It is also called explanation of stages of law of variable proportion. So what we are discussing is basically explanation of various stages of law of variable proportion. As you all already know, there are 3 stages that we have been referring to constantly. There are 3 stages that we have been constantly referring to. Sir, what are those 3 stages? Increasing, diminishing, and negative. Increasing, diminishing, and negative. Okay, so let me put it forward for you. Increasing returns, then you have diminishing returns, right? Increasing returns, then you have diminishing returns. Let me write it down for you again: increasing return, diminishing returns, and finally for you there is negative returns. So there are 3 stages: increasing, diminishing, and negative returns. We are studying why these stages operate. Now see, let's talk about increasing return. Why? Let's answer the question why. Pay attention, friends. You see, when there is one fixed factor, let's say a machinery or let's say a piece of land. Okay. Now you hire one laborer. Now, when you hire one laborer, the land is not fully utilized. That is, the fixed factor is not properly utilized because such big piece of land only single laborer can't cover. Now, suppose only one labor is working on that land. Labor is the variable factor. Labor is the variable factor. Land is the fixed factor. Now, see what is the problem here. When labor is working on that piece of land, when a laborer is working on that piece of land, when a laborer is working on that piece of land, when a laborer is working on that piece of land, now what is happening, friends? What is happening when a laborer is working down that piece of land? My dear friends, when the laborer is working on that particular piece of land, now, what is happening? My dear friends, what is happening is that the laborer is doing all the work. So labor is cultivating the field, is putting in the plants, is chopping of the wheat. So all the work is done by one person. So the variable factor is not being used efficiently. Similarly, the land, that is the fixed factor, is also not used efficiently. But suppose you hire 5 laborers now. Now what will happen? The laborers will be able to work efficiently. Why? Because they will divide work among themselves. Similarly, land. Now a greater portion of land will be utilized because single laborer could not cover the entire piece of land. So why does increasing returns operate? Or for the 2 reasons. What is the 2 reasons? Better utilization. Better utilization. This is the common point. and then you divide it into two. Better utilization of variable factor, that is, see, labor is dividing work among themselves, so each labor is better utilizing their capacity, and similarly the land's capacity is better utilized, and so better utilization of fixed factor. This covers both of our points, isn't it, my dear friends? Isn't it simple? Sir, can you explain it in Hindi? क्या आप इसे हिंदी में समराइज कर देंगे? Yes, I will summarize it in Hindi for you all. Okay, pay attention. देखिए, इंक्रीजिंग रिटर्न्स क्यों होता है? शुरुआत में आप मान लीजिए एक फिक्स्ड फैक्टर है आपके पास, जमीन, ठीक है, लैंड, और एक वेरिएबल फैक्टर आपके पास लेबर या मजदूर, ठीक है। अब देखिए प्रॉब्लम क्या हो रहा है, जब एक लेबरर काम कर रहा एक पर्टिकुलर मशीन पर या मान लीजिए एक जमीन पर, तो प्रॉब्लम ये है कि वो जमीन इतना बड़ा है कि एक लेबरर पूरा उसे यूज नहीं कर पा रहा। तो पहली बात तो जमीन पूरी तरह से इस्तेमाल नहीं हो रही है, दूसरी बात अब लेबरर को सारा काम खुद करना पड़ रहा है, तो जो वेरिएबल फैक्टर है यानी कि लेबरर, वो खुद भी एफिशिएंटली काम नहीं कर पा रहा। लेकिन जब आप 5 या 6 लेबरर्स को हायर कर लो तो होता क्या है, हर लेबरर अपने एफिशिएंसी पे काम करेगा, क्यों? क्योंकि उन लोग काम बांट लेंगे। तो एक तो वेरिएबल फैक्टर बेहतर यूज हो रहा है, दूसरा जमीन भी ज्यादा कवर होगा, पूरा जमीन कवर हो पाएगा, जो कि पहले नहीं हो पा रहा था। माय डियर फ्रेंड्स, यही मैं आपको कह रहा हूं, इस वजह से इंक्रीजिंग रिटर्न्स ऑपरेट करता है, इस वजह से इंक्रीजिंग रिटर्न्स ऑपरेट करता है। आई होप इट्स क्रिस्टल क्लियर फ्रेंड्स। यस और नो प्लीज, यस और नो प्लीज। Okay, yes, sir. Very good. Now we talk about diminishing factor. Why does diminishing factor occur? Why does law of diminishing returns take place? So let me answer this question for you all. A very simple question indeed. A very simple question indeed. Why does the law of diminishing returns operate? Okay, so let me answer this for you. See, there is a limit. There is a limit. There is a ratio limit. Like for example, one piece of land, 10 laborers can work at best. So once you have reached this best limit, beyond this, if you put more laborers, productivity might increase, but only a certain bit, only a certain bit. It cannot increase by much. Productivity will increase, but will it increase by much? I'm sorry, it will not increase by much. It will increase only by a little bit. Yes, sir, you are right, sir. That's diminishing returns. I'll give you an example. I'll give you an example. All of you have seen this example. Guys, you all tell me, all of you have had sometime in the life sugarcane juice, yes or no? In Hindi, we call it ganne ka ras. All of us have had it, right? Now, you all know the machine through which the sugarcane is rolled, right, or crushed. Now, pay attention, my dear friends, that machine is a fixed factor. The sugarcane is a variable factor, and the juice produced is the output. Juice produced is the output. Now, what does that person do? They take up one sugar cane, they'll put it into the machine. The machine is crushing the particular cane and juice is extracted. Now what they do? They again take that out and again put it into the machine. Now this time also the same originally crushed sugar cane will generate some juice. But will it be as the same quantity as the previous one? No. Whenever the optimum combination is disturbed, you might get some extra juice. You might get some extra juice, but it will not be by much. That's what diminishing returns is. The total productivity will rise. The total productivity will rise. The total productivity will rise, but not as the previous case. You know, when you insert the fresh cane into it, you will find a lot of juice being extracted out of it. But when the same crushed can is already again put into the machine, does it put the same amount? Absolutely not. It doesn't generate the same quantity of juice. Reason is it has been properly utilized. That's what about diminishing returns. When the optimum labor combination is disturbed, then diminishing returns strike. Oh, so what we will write here? When optimum combination is disturbed. When optimum combination is disturbed. When you disturb the optimum combination of what? Of the factor and the fixed factor and the variable factor. So Now productivity will increase slowly, slowly. Understood, sir? Understood. Sir, can you explain it in Hindi also? Okay. देखिए, जब आप ज्यादा से ज्यादा प्रोडक्शन करते हैं, ज्यादा से ज्यादा आउटपुट जनरेट करते हैं, तो जब आप इनपुट इंसर्ट करते हैं, है ना, शुरुआत में क्या होता है कि वेरिएबल फैक्टर कम होता है, फिक्स फैक्टर ज्यादा होता है। बट जैसे जैसे एक ऑप्टिमम कॉम्बिनेशन होता है कि जहां पे वेरिएबल फैक्टर और फिक्स फैक्टर अपना बेस्ट परफॉर्म कर रहे हैं, उसके बियॉन्ड आप और वेरिएबल फैक्टर अगर लगाओगे तो क्या होगा कि वेरिएबल फैक्टर फिक्स फैक्टर को पूरी तरह से सब्स्टिट्यूट तो कर नहीं पाएगा। वेरिएबल फैक्टर विल नॉट बी एबल टू सब्स्टिट्यूट द फिक्स फैक्टर एग्जैक्टली, right? And so the output will increase this time, but not with the same vigor, with the same strength as the previous one. Now it will be a little lesser, and so MP is falling, AP is falling, okay, in diminishing returns. And what is negative returns, sir? This is called the problem of overcrowding. You have heard the phrase, too many cooks spoil the broth. So something like this is happening. Now negative returns have started taking place because there is now management problems, overcrowding. Management is finding it difficult to, keep cooperation between laborers, keep a sense of discipline amongst them, and therefore overcrowding problem leading to this particular kind of stages, increasing, diminishing, and negative. Increasing, diminishing, and negative. Is that clear, friends? Is it clear, friends? So नेगेटिव रिटर्न्स होता है जब आपका जो आउटपुट है वो एकदम नीचे गिरने लग गया बिकॉज आपने हद से ज्यादा लेबरर्स को अपॉइंट कर दिया। ये तो हद पार हो गया। अब पता चला कि लेबरर्स लोग इतना ज्यादा हो गए हैं कि वो लोग हड़ताल करने लगे हैं, क्राउडिंग हो गया है, मैनेजमेंट संभाल नहीं पा रही है लेबरर्स को। दैट इज द प्रॉब्लम। दिस इज द प्रॉब्लम दैट हैज टेकन प्लेस। आई थिंक माय डियर फ्रेंड्स यू हैव अंडरस्टूड ईच वन ऑफ यू of what is going on. Yes or no, friends? Yes. So the reason behind each stage. Now I'll ask you a question. Let's see whether you are able to answer this time or not. See, stage 1 operates due to. Why does stage 1 operate? Is it due to overcrowding problem? Is it because of the optimum factor proportion being disturbed? Is it because fixed factor is being better utilized, or none of the above? Why does stage 1 operate? What do you think, my dear friend, is the answer? Now you will answer it. Come on, everyone. You must answer it. Come on, friends. Wow. Yes, sir. So the answer is absolutely correct. Sir, stage 1 operates due to better utilization of fixed factor. Overcrowding leads to negative return, stage 3. Disturbing optimum factor proportion is stage 2. And therefore, your correct answer is option C. That's right, friends. That's right, friends. Absolutely. Overcrowding leads to stage 3. Disturbing optimum factor proportion, stage 2. And better utilization is absolutely stage 1. No question asked. Okay. Now let's move on, guys. Let's move on, guys. Now, my dear friends, there was a problem with law of variable proportion. Did you notice what? That their factor proportions can be changed. I will write it again for you all. My dear friends, in law of variable proportion, factor proportions can be changed. Factor proportions can be changed. Yes, it was possible to change the factor proportions. Yes, it was possible to change the factor proportion. Sir, what does it mean? Like suppose fixed factor is 1 only. Now variable factor you are constantly increasing. So initially the ratio was 1:1. 1 fixed factor, 1 variable factor, then 1:2, then 1:3, then 1:4, then 1:5, and then 1:6. This was the change in ratios, isn't it, sir? Yes, my dear friends, it was it. And therefore, here factor proportions are being changed. Here factor proportions are being changed. That is the problem taking place here. Now we talk about laws of returns to scale. Under what scale does, or under what scenario does law of returns to scale operate? Yes, you people are absolutely correct. It operates in the long run. If you all remember the notes of the last class, I had told you that law of returns to scale operates in the long run. Law of returns to scale operates in the long run. Here, factor proportion cannot be changed. Not possible to change factor proportion. Meaning, sir, what does it mean that it is not being changed? Means if there is one fixed factor and 4 laborers, then in order to increase laborers, you will also have to increase fixed factor. There will be 8 laborers. You cannot go like 1:4, 1:5. Ratio cannot change. The ratio will remain the same. You see, this is also 1:4. 2:8 is also nothing but 1:4. Similarly, 3:12 is also nothing but 1:4. 4:16 is also nothing but 1:4. Yes or no, friends? Yes or no, friends? Yes, sir. So, my dear friends, that is the idea. That is the idea. That is the idea. And therefore, law of returns to scale. My dear friends, remember, it operates in the long run and it is not possible to change factor proportions here. Acha, it operates in the long run. Exactly. Like you see here in this case, 1:4 is the ratio. So in order to increase land, we have to increase labor to 2:8. We have to increase the labor to 2:8. In order to increase further, we have to take it in the form of 3:12. In all the cases, the ratio you will find out is 1:4. That, my dear friends, is law of returns to scale. Okay, got it. So to simply summarize it, or to simply sum it up, there are following differences between law of variable proportion and law of returns to scale. So what are the differences? Number one, law of variable proportion operates in the short run. And in what time period does law of returns to scale operate? Law of returns to scale operates in the long run. Law of variable proportion operates in the short run. Law of returns to scale operates in the long run. In law of variable proportion, there are two scenarios. There are fixed factors and then there are variable factors. In law of variable proportion, there are two scenarios. Fixed factor and variable factor. But in law of returns to scale, there is only fixed factor. There is only variable factor. There is nothing called fixed factor. Why? Because in the long run, all the factors can be increased or declined. You can buy a new piece of machine. You can employ more labor. You can buy additional raw material. So nothing is there which cannot be changed in the long run. And hence, only variable factors can be seen in the long run. Got it, sir. And what about, sir, factor ratios? Law of variable proportion, factor ratios could be changed. So let's say if there was one machine, 2 laborers, you could, let's say, increase it to 1:3. You could, let's say, increase it to 1:3. But here, law of returns to scale, factor ratio cannot be changed. So if it's 1:2, it will stay in the form of 1:2 only. If you want to increase it, it will be in direct proportion. So 2:4, it has to become. It has to become 2:4. Okay, got it, sir. My dear friends, is the two crystal clear? Chahiye dono crystal clear reference? Yes or no, please? Is that crystal clear? Come on. So now let me ask you an MCQ question again. 6th MCQ question for the day. Let me ask you, under which law can factor proportion not be changed? Under which law can factor proportion not be changed? I'm not saying be changed, not be changed. Here are your options. A, law of variable proportion. B, law of returns to scale. C, law of diminishing marginal utility. D, none of them. What do you think will be the answer, friends? Come on, everyone. Come on, everyone. Under which law can factor proportion not be changed? So, my dear friends, the answer is factor proportion cannot be changed in laws of returns to scale. Factor proportion cannot be changed in laws of returns to scale. And they are saying which law can factor proportion not be changed. And so the answer is law of returns to scale. That's right. Your answer is law of returns to scale, the one that operates in the long run. The one that operates in the long run. Okay, sir. So, sir, just like in variable proportion, you had different stages. In returns to scale also are there stages? Yes, there are 3 stages again. First of all, let's revise the variable proportion 3 stages. What were they? Increasing returns to factor, then there was diminishing returns to a variable factor, and then there was negative return. So in variable proportion, it was increasing returns, diminishing returns, and negative returns. Again, I repeat, In variable factor, in the case of variable factor, you had increasing returns, diminishing returns, and negative returns. In the case of variable factors, you had increasing returns, diminishing returns, negative returns. What did you have? Increasing returns, diminishing returns, negative returns. I repeat, increasing returns, diminishing returns, and negative returns. It was there in the case of absolutely correct in the case of variable proportion. But when you talk about returns to scale, hello, when you talk about returns to scale, there are three cases. In returns to scale, the three cases are increasing returns to scale, constant returns to scale, decreasing returns to scale. What are they? Increasing returns to scale, constant returns to scale, decreasing returns to scale. I repeat, increasing, constant, and decreasing. Please remember, here there is no word called diminishing. Here there is no word called negative. Here it's increasing, constant, and decreasing. Increasing, constant, and decreasing. Increasing, constant, and decreasing. Here the three words used are increasing, constant, and decreasing. Increasing, constant, and decreasing. Increasing, constant, and decreasing. Yes, sir, we understood. Yes, sir, we understood. So these are the three stages. The three are increasing, constant, and decreasing. Now let's talk about each one of them. Suppose there is one piece of land and two labor. Now suppose land is doubled. Land is 2, labor is 4. Initially, what was the output? 100. When there was one land, two labor, the output was 100. But when you doubled them, when you doubled the land and you doubled the labor, the output got more than double. The output became 250. The output became 250. Yes, my dear friends, that's what increasing returns to scale is all about. That's what increasing returns to scale is all about. What is it all about, sir? Here you are increasing it at a greater pace. So as you can see here, when land is doubled, labor is doubled, output is getting more than doubled. So output is not becoming from 100 to 200. It's becoming 250, 300, 400 for that matter. That's increasing returns to scale. The graph of increasing returns to scale is relatively flatter one. Flatter one, flatter one. Please remember this. The graph of increasing returns is relatively a flatter one. Got it? So once you see this, you see land is 1, labor is 2. When land became 2, labor became 4. So when all these was doubled, output got more than doubled. Output got more than doubled. And so the answer is increasing returns to scale. That's fantastic. That's fantastic. Now moving on. Constant returns to scale. Here, when input is doubled, output is exactly doubled. Meaning land C, 1 say 2, labor 2 say 4. So it has doubled. Now see output 100 to 200, exactly double. If it was more than double, it would have been increasing returns to scale. But if it is exactly double, it's constant returns to scale we are talking about. Okay. And finally, absolutely, decreasing returns to scale. Here output will increase, but with a lesser pace. For example, see, land is doubled from 1 to 2, labor is doubled from 2 to 4. So both the inputs are doubled. Both the inputs are doubled. But you see, output is less than double. Yes, output has increased, but it is less than double. That, my dear friends, is called decreasing returns to scale. What is it called? It's called decreasing returns to scale. When output is not getting exactly doubled, when output is getting less than 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 doubled, that, my dear friends, is representative of decreasing returns to scale. Decreasing returns to scale. Sir, we got it. Now, let's talk about this question, and see whether you are able to answer it or not. Initial output was 100 units. Initial output was 100 units. Initial output was 100 units. When input was tripled, when input was, yes, tripled. When input was, yes, tripled. When input was, yes, tripled. Output was 320 units. Okay. So what stage are we talking about in the returns to scale? Is it increasing returns, decreasing returns, or a constant returns? Remember, there is nothing called diminishing returns here. It's decreasing returns, not diminishing returns. Come on, tell me the answer, friends. And why do you say so? Also the reason behind your answer. Come on, friends. Let's hear you out. Okay. So as I can see, there are answers coming along. And yes, our friends have told the answer to be A, increasing returns to scale. As you have correctly mentioned, our answer is A, increasing returns to scale. A, increasing returns to scale. Because see what is happening. Initially output was 100. When input was tripled, so input got into 3, but output increased from 100 to 320. So if you look carefully, output increased by 3.2 times. So the rise in output was more than the rise in input, because input got into 3, output got into 3.2, and therefore increasing returns to scale. ये बिल्कुल सही है, you all are correct, absolutely correct. So here it is, my dear friends. If the change in output, they have pointed it out absolutely correctly and fantastic way. They are telling you that if the change in output is greater than change in input, it's increasing returns to scale. You just write it down, and this is the entire summary of things in this chapter, in this particular stage. If change in output is exactly equal to change in input, if change in output is exactly equal to change in input, if change in output is exactly equal to change in input, yes, you are talking about constant returns to scale. Yes, you are talking about constant returns to scale. That's right. And when change in output is less than change in input, if change in output is less than change in input, if change in output is less than change in input, that, my dear friends, is called decreasing returns to scale. That, my dear friends, is called decreasing returns to scale. That, my dear friends, is called decreasing returns to scale. Sir, we got it. We got it, sir. We got it, sir. And therefore, your answer to this has been explicitly established. So when change in output is greater than change in input, we call it increasing returns. When change in output is exactly equal to change in input, we call it constant returns. And when it is in a lesser proportion, we call it decreasing returns to scale. We call it decreasing returns to scale. I hope it's crystal clear, friends. Yes, sir, it's crystal clear. Now. There is one good knowledge in our book that we must, apply here. That is related to or derived from Cobb-Douglas production function. Okay. So let me bring you back to the same. You all must remember the Cobb-Douglas production function that we gave you. Okay, that I taught you. Cobb-Douglas. We did it in last day. Cobb-Douglas production function. It was somewhat like, let's say Q is a constant, and then there is a K. Q is a quantity and K is a constant. Labor is, let's say, raised to the power A. Capital is raised to the power B. But yes, sir, you told 3/4 and 1/4. Yes, that's right. But that was in perspective of production function. Now pay attention. There is an interesting thing I will tell you. A and B show the contribution of labor. A and B show the contribution of labor. Right? So remember, A and B represent contribution to output. Okay? So if A and B together is greater than 1, that's called increasing returns to scale. We are talking about long run, my dear friends. Please remember this. If A plus B is greater than 1, you are witnessing the world of increasing returns. Another way to identify increasing returns. Okay. If A plus B is exactly equals to 1, you are in the world of constant returns to scale. This is another method of identifying returns to scale. You are in the world of constant returns to scale. Okay. And if you are in the world of A plus B less than 1, you are talking about decreasing returns to scale. Yes, you are talking about decreasing returns to scale. That's right. You are talking about decreasing returns to scale. Absolutely, sir. Yes, sir, we get it. So there are 3 stages: increasing returns to scale, constant returns to scale, and decreasing returns to scale. Absolutely correct, my dear. Absolutely correct. Now. Pay attention, friends. Pay attention. Okay. Now, one more question that I have from the MCQ part. Please tell me. The quantity ratio is written as K, right? K L 5/4, C 3/4. Which stage of returns to scale is witnessed here? Which scale is witnessed here? Come on, friends. Which scale is witnessed here? Come on, friends. What say? Give me the answer. Let's hear it out. This is the Cobb-Douglas question. Okay, great. Absolutely. So our friends are correct when you are stating that yes, sir, that's increasing returns that we are referring to. So as you can see here, if you see A plus B, that is 5/4 plus 3/4, it's giving you value of 8/4, which is 2. And so the stage being referred to is increasing returns to scale. The stage being referred to is increasing returns to scale. The stage being referred to is increasing returns to scale. We got it, sir. And so stage 1, obviously. Moving on. Now we get into another sweet discussion that's called production optimization. Something like production optimization we have already done. No, sir. This is the first time we are doing. No. We have done it. Sir, where? I'll tell you now. All of you remember consumer equilibrium? All of you remember consumer equilibrium? Yes, sir, we remember. We do remember consumer equilibrium. Yes, sir, we do remember consumer equilibrium. So, my dear friends, in consumer equilibrium, come on, pay attention. Huh? In consumer equilibrium, what was happening? A consumer was arriving at equilibrium. Agreed? Huh, sir? So, what is new here? Whenever the consumer was arriving at equilibrium, we were drawing two graphs. Can you tell me the names? Yes, sir. You taught us in consumer equilibrium the two graphs that you told us was, sir. Number one was this indifference curve, and the other two, and the second one was budget line. So indifference curve and budget line we had drawn, and the point of intersection of indifference curve and budget line, that is the point of tangency we call it. At the point of tangency of indifference curve and budget line, at the point of tangency of indifference curve and budget line, if you all remember, we had our equilibrium achieved. Do you remember that? Yes, sir, this is correct. We remember. Similar to that, now the producer's equilibrium will be achieved. Just like there was indifference curve and budget line, here there is iso-quant and iso-cost. So you remember the indifference curve that was convex to the origin in consumer equilibrium chapter? Yes, sir, we do remember. That is iso-quant here. Acha. And you remember budget line? Consumer had a budget. So budget line, similarly, producer has a budget. That budget line in production chapter is called iso-cost. It's called iso-cost. Iso-cost, iso-cost. Acha. Now, sir, it's looking easy. So production optimization is much like consumer equilibrium. Much like consumer equilibrium. Here we are discussing how to optimize production. Now there are two topics here, indifference curve and budget line. Indifference curve is nothing but the name of iso-quant, and budget line is replacing iso-cost. So iso-cost is for production, budget line is for consumption. Similarly, iso-quant is for production, indifference curve is for consumption. Understood, sir? Each one of them we understood. Let's go ahead. So iso-quant behaves like indifference curve. Remember, I repeat it for you. Iso-quant is much like indifference curve, and iso-cost is much like budget line. With that being said, let's talk about iso-quant. Iso-quant. You all remember indifference curve definition? In indifference curve, we had studied indifference curve is a various combination of two commodities that result in same satisfaction. You remember? Iso-quant is various combination of two inputs. Let's say the inputs are labor and capital. So various combination of labor and capital. like 8 units of labor, 2 units of machine, or 1 unit of labor, 5 units of machine, or 7 units of labor, 3 units of machine. Many combinations of labor and capital, many combination of labor and capital, all resulting in same quantity of output being produced, all resulting in same quantity of output being produced. So if you have a look here, let me show it to you. Let me show it to you. What is it written? Various combination of two inputs that give the exactly same output. Various combination of two inputs that give the exactly same output. Various combination of two inputs that give the same output. Various combination of two inputs that give the same output. I repeat, various combination of two inputs that give the same output. We are talking about that here. Various combination of two inputs that give the same output. Acha, is that so? So that is what iso-quant is. Iso-quant is. Now let's say, for example, combination A, 1 factor X and 12 of factor Y. B, 1 more factor X employed, but now 8 units of factor Y. Here, there was marginal rate of substitution. Remember? Here there is marginal rate of technical substitution, MRTS. Same logic. To increase factor X by 1 unit, you have to decline factor Y by 4 units. Further, to increase factor X by 1 more unit, you have to decline factor Y by 3 units. Again, to increase factor X by 1 unit, you have to decline factor Y by 2 units. Again, to increase factor X by 1 unit, you have to decline factor Y by 2 units. And this, my dear friends, 1 unit. This, my dear friends, is MRTS. Now, the curve is negatively sloped, convex to the origin. Why is it negative slope? You remember in indifference curve, same logic. Here it is negative slope because to increase the consumption of factor X, you have to reduce the consumption of factor Y. I will repeat, to increase the consumption of factor X, you have to reduce the consumption of factor Y. And therefore, the negative slope. And therefore, the negative slope. Point number 1. Point number 1. What is point number 2? It's convex to the origin. What does it mean, convex to the origin? It means MRTS is declining. It means MRTS, marginal rate of technical substitution, is declining. It means marginal rate of technical substitution is declining. So declining MRTS. Declining marginal rate of technical substitution. See, it is constantly falling down. MRTS is constantly falling down. So therefore declining MRTS. This is the shape. We got it. And one more thing, remember. Again, like indifference curve, two isoquants will never intersect. Two isoquants will never intersect. Number 1. And number 2, higher the isoquant, higher the satisfaction. Just like indifference curve, higher the indifference curve, higher satisfaction. Higher the isoquant, higher the satisfaction. Why? Because higher isoquant implies more output being produced. Higher isoquant implies more output being produced. Higher isoquant implies more output being produced. Since higher isoquant implies more output being produced, and therefore more the satisfaction, more the upper the isoquant. Sir, we get it. Got it. We got it. Now we talk about isocost. After isoquant, we move to isocost. Now isocost is like budget line. Isoquant was like indifference curve. Isocost is like budget line. Remember. See, just like consumer had a constraint, consumer had a budget, they cannot spend or consume more than the budget. Same way, producer has a budget. They cannot, employ and incur costs more than the budget. And so, my dear friends, isocost is much like budget line. Isocost is much like budget line, and it is downward sloping. Okay. And when is production optimized? Production optimization is happening when at least cost maximum output can be produced. When at least cost, कम से कम कॉस्ट में ज्यादा से ज्यादा आउटपुट प्रोड्यूस हो पाए. कम से कम कॉस्ट में ज्यादा से ज्यादा आउटपुट प्रोड्यूस हो पाए. My dear friends, all of you have come from class 12 in CA foundation level. You all will remember in, either you were in ISC board or in CBSE board. You had a subject called commerce or business studies. You remember? Yes. There were principles of management that you studied. Yes, sir, we do remember. Then there was Taylor's scientific principles of management. There, what did Taylor say? Management is the art of knowing what you want your people to do and seeing that they do it in the best and the cheapest way possible. You remember this? Yes, sir, we have studied. That is production optimization. Best and the cheapest way. So most output at cheapest cost. Most output at cheapest cost. That is production optimization. That is production optimization. Oh, yes, sir. That is production optimization. Yes, my dear friends, that is it. Now, where is equilibrium or where is optimization taking place? Where is equilibrium or where is optimization taking place? Again, the same old boring answer, friends. I'll give you a same old boring answer, sir. I'll give you the same old boring answer, sir. What would that be, sir? My dear friends, at the point of tangency. That is where the indifference curve and the budget line meet each other. That is at the point where the indifference curve and the budget line meet each other. It is at the point where the indifference curve and the budget line meet each other. That was in consumer equilibrium. Here where the isoquant and isocost meet each other like a tangent. Like a tangent. That's right. It's like this. That is the condition. So when isoquant is equal to isocost, that is a tangent, not at 2 points, just at 1 point they meet. Then they are called tangents. Okay. And that is the condition of equilibrium to be achieved here. Okay, sir. Now, let me ask you some questions, friends, to understand how much you have understood whatever we have done. All right. Let's see. See, my dear friends, when we discussed, now let me ask you some questions, okay? Here I come. Okay, let's see. Point 1. Question 7 for the day. Isoquants are downward sloping option A, straight line, B, convex to origin, C, concave to origin, D, none of these. What say, my dear friends? What do you think is the correct answer? Come on, friends. Come on, friends. What do you think about isoquants? Absolutely. Absolutely. Very good. See, isoquants are downward sloping as well as, you all are absolutely correct, as well as they are convex to the origin. As well as they are convex to the origin. So your answer that they are convex to the origin is absolutely correct. Is absolutely correct. Very good. Next question. Answer me this. Isocosts are A, downward sloping, straight line, B, downward sloping, convex lines, upward sloping, straight line, D, none of these. What do you think is the answer, my dear friends, in isocosts? Come on, let's answer this. Tell me. So you are absolutely correct when you say that isocosts are downward sloping straight lines. Absolutely correct. You are absolutely correct when you tell me that isocosts are downward sloping straight lines. Absolutely, yes. Next question. Next question. Why is isoquant convex to origin? Option A, due to diminishing marginal rate of substitution. B, due to diminishing marginal rate of technical substitution. C, due to constant MRTS. D, none of above. What say, my dear friends? What do you think is the answer? Why is it convex to the origin? Why is it convex to the origin? Okay. Come on, friends. Absolutely correct. Absolutely correct. Congrats, Harshit. Good work. Good job. All right. C. Why is isoquant convex to the origin? And yes, you all are absolutely correct when you say due to diminishing MRTS, diminishing marginal rate of technical substitution, due to diminishing marginal rate of technical substitution, due to diminishing marginal rate of technical substitution. That's right, sir. Due to diminishing marginal rate of technical substitution. What does it mean, sir? What does it mean, sir? I will remind you again. So suppose there are two factors, right? Let's say factor X, variable factor, then there is factor Y. Or let's say both are variable. Okay. Now, suppose you are using 1 unit of factor X. So 12 units of factor Y you are using, and then you are producing some output. Factor means input. Okay. Now you increased factor X by 1 unit. So factor Y had to be reduced by 4 units, and so you have reduced it to 8 units. Again, factor 3 when you increased, now you have how many units left? 5 units. Again, when you increased further, again when you increase it further, then what will you observe? Then what will you observe? It is 3. So if you see the technical substitution, to increase one input, how many inputs sacrificed? 4. Again, to increase 1 unit, how many inputs sacrificed? 3. Again, to increase 1 input, how many units of other input sacrificed? 2. This is called declining MRTS or diminishing MRTS, as you can see. Why is isoquant convex to the origin? Diminishing MRTS. Acha, due to diminishing MRTS is what you are saying, sir. Yes, due to diminishing MRTS. That's right. That's right, friends. Right. Let's see the 10th one. Let's see the 10th one. Okay. Let's see whether we are able to solve it or not. Come on, friends. Question number 10. Question number 10. Let's hear it out. So if we talk about question number 10, let's not talk about question number 10. I'll teach you one more thing, one more concept. All right. And then we will solve MCQs. Okay. Assumptions of, what are we studying? Assumptions of law of variable proportion. Assumptions of law of variable proportion. Assumptions of law of variable proportion. Assumptions are, things in mind that needs to be kept constant, or that need to be kept in mind before you study that law. If you remember, in law of DMU, that is law of diminishing marginal utility, we had studied some exceptions. Similar to that, if you want to study law of variable proportion, or if you want law of variable proportions to work, there are certain exceptions yet again. Let's have a look at some of them. Okay, see. Point A. First of all, number one assumption is we are in the short run. Assumption 2 is also very obvious to you, that there are two types of factors. Can you name them? In law of variable proportion, what are the two types of factors that you will have, or the inputs that you will have, the two types? Come on guys, tell me, write down in the chat. Yes, absolutely correct. Sir, variable factor and fixed factor. That's right. Variable factor and fixed factor. Point C is very important. That no new technology is coming into the picture. Because suppose if you bring in new technology, again increasing returns will start. So when we are studying this law, no new technology we are bringing into the picture. So no changes in technology while we study this law. No changes in technology while you study this law. Point D. What is the point D? Point D is, we assume, this is a very big assumption. In reality, it's not the case, it's not the truth, but we assume it, that all units of variable factor are equally efficient. So what are you assuming? That all the variable units that you have, that is all the laborers that you have, they are equally workable, they are equally good. In real life, does it happen that all people are equally good in the same kind of work? Absolutely not. The deviation is always there, maybe by little, but the deviation is always present. Deviation is always there, and hence the logic. So these are the four assumptions, major assumptions of the law of variable proportion. Could you sum it up for us, sir? Yes, the main assumptions, I would say. There are many more, but these are the main assumptions, right? So the first assumption is that we are working in short run. Number two, there are different types of factors, variable and fixed. That is, there is no new change in technology, that is, new technology is not coming into the picture, and all units of variable factor are equally efficient. So you know that all laborers are equally efficient, or all raw materials are equally good. Okay. Now one of our friends is telling to summarize it in Hindi. So to summarize it in Hindi, law of variable proportion का ये assumption है कि हम लोग short run में काम कर रहे हैं, जहां पर दो तरीके के फैक्टर है, फिक्स्ड और वेरिएबल. हमारा assumption ये है कि जिस दौरान हम लोग लॉ ऑफ वेरिएबल प्रोपोर्शन स्टडी कर रहे हैं, उस दौरान हम लोग पिक्चर में कोई नया टेक्नोलॉजी लेकर नहीं आएंगे. और लास्ट assumption कि देखिए, जैसे जो इनपुट्स है, जो वेरिएबल है, जैसे लेबर, रियल लाइफ में क्या हर लेबर इक्वली एफिशिएंट होता है क्या? नहीं सर, कोई ज्यादा होता है, कोई कम. हम लोग मान रहे हैं इस लॉ के अंदर कि हर लॉ ऑफ वेरिएबल प्रोपोर्शन के अंदर हर जो लेबरर आप यूज कर रहे हो या हर जो इनपुट आप यूज कर रहे हो, जो वेरिएबल फैक्टर है, वो इक्वली एफिशिएंट है, इक्वली केपेबल है. ये एक अजम्पशन चल रहा है. ठीक है? ओके सर. So yes, this is crystal clear. Yes, this is crystal clear, sir. Yes, this is crystal clear. So one more question that I am getting, which is not really a very good question, which is not a good question. The question's answer I have already given. That, sir, how will I make study material? The answer is very simple, as I have already told you. The answer is very simple. The study material, the best one is you study the institutes material that you get, right? You are talking about summary charts. Institute website itself has summary charts, if you find out, of all the chapters, right? So this is enough. As far as our class is concerned, whatever I am saying, you know, whenever there is something to be noted down, I take a pause. So you may note it down. But otherwise, If you want to do well in eco, these two are sufficient, right? So now moving on. Now moving on. Now moving on. Let's talk about the questions further. Let's talk about the questions further. Another question that I have in mind is, which of the following is true for Cobb-Douglas production function? Q equals to K C A L B. Options A. K is constant. Option B. A is a constant. Option C. B is a constant. Option D. All the above. All above. Now you will answer me. Which one do you think is clear? Which one do you think is the correct answer? Very good. I'm waiting for the answer, mates. So let me give you the answer. Yes, K is constant, A is constant, and B is also constant. So all of the above is true. If you revise the last day's concepts, you will find it out. In Institute's material, it's written, I had discussed it in the last class. K, A, and B, all the three are a constant. Okay? Please remember this. Okay. All right. Next. When isocost line is tangent to isocon, when isocost line is tangent to isocon, when isocost line is tangent to isocon, we get, you have the four options available with you. Please answer them one by one. You have four options available with you. Please answer them one by one. Option A. Producer's equilibrium. B. Production optimization. C. Consumer equilibrium. D. None of above. What say, friends? What do you think is the correct answer? What do you believe is the correct answer? Remember, here, if there is a fight between producer equilibrium and production optimization, you will always choose production optimization, because that is the word we use. Producer equilibrium is used to show the profit scenarios. So therefore, better not use that word. That is why I gave you this question. The correct word you will use is production optimization. Production optimization. I told you now, production optimization. So you get production optimization. B is the correct answer. B is the correct answer. B is the correct answer. Okay. So it's not the equilibrium. That's why I gave you to test whether you answer equilibrium or not. It will give you production optimization. You know, we have discussed this. In fact, I will show you my notes as well. We have discussed this. So here we come. If you see production optimization, we had written it. Least cost max output. Okay. So when is equilibrium word used? To indicate profits. When is it used? To indicate profits. Here there is no profits as such taking place. and therefore we don't talk about the same. Therefore, we don't talk about the same. Right. Now, sir, the fact that you have discussed this, another question comes to my mind. Let me ask you the same. Let me ask you the same. Calculate on the basis of data. I am giving you a question data, okay? Okay? I am giving you, okay? This is labor. Okay. Let me draw it for you. Yes, you have to fill in the gaps. Okay, I'm giving you a question, and then come on, answer this, my dear friends. So remember, my dear friends, come on, you will have to fill in the blanks. I'm giving you 2 minutes to think of this because it will require some thinking, a lot of blanks to be fulfilled. You know, so many questions asked together. Answer this. Come on, sir. Very good. I can see some answers. Wow. See, for the first unit, TP, MP, and AP all will be same because when nothing was produced, when no labor was there, nothing was produced. So change in labor is by 10. So for first unit, MP is 10. And what is average product? Average product is nothing but total product divided by labor. So see, TP is 10, labor is 1. So 10 by 1, 10 by 1 is equal to 10. Because 10 units of total product, 1 unit of labor, so T 10 by 1 is 10. Now, marginal product is 12. Now, if marginal product is 12, it is increasing by 12. So, 10 increased by 12, how much does it give you? It gives you 22. Yes or no? 10 increased by 12. Because MP means additional. So, already 10 was produced, now additional 12 is produced. So, total 22 is produced. Now, how will you calculate the average? 22 by 2, which is 11. Oh, sir, we get it. Similarly, now marginal product you increase further by 8. So total product is again 30. Again, the average will be 30 by 3, which is equal to, you are correct, 10. Now pay attention, friends. Now pay attention, friends. What I'm telling you all is a simple thing. At the fourth unit, AP is 9. Now you will see what is AP. AP is total product divided by labor. So if AP is 9, all right, TP you don't know, but labor you know at fourth unit. So what would TP, total product, be equal to? What would TP, total product, be equal to? You all guessed it correct. Sir, 9 4s are 36. That's right, fantastic. So my dear friends, we put the 36 here. Now from 30 to 36 it has become. So by how much it has increased? It has increased by 6. Further talking. Now you see. Again, average product is total product by labor. Now average product is 7. Total product we don't know. But labor is 5 units this time. So total product is 7 5s are 35. So it became 35. Now if it has become 35, 35 minus 36 is how much? Minus 1. Oh my God. Sir, it is absolutely crystal clear. Is that crystal clear, friends? Yes or no, please? Yes or no, please? Very good. I can see Shreya giving all the answers. Absolutely, Shreya. Soham, Arpi, good one. Come on, guys. Is that crystal clear? Please check your answers. All right. I will definitely come to your answer. Book institute material also. Okay. Okay, great. Correct, correct, correct. So let me make for you some formula sheet. Okay, please write down some formulas. I'll write it down for you all. See, formula number 1 is marginal product at any level. Remember, marginal product. If you talk about marginal product at any level is total product at that level minus total product at a level lesser than 1. TP of n minus TP of n minus 1. Again, if you want total product at any level equals to marginal product up to that level, that is for the first unit or the second unit, up till n units you will keep adding. Up till n units you will keep adding. Example, if you need a total product of 4 units, then marginal product of first, marginal product of second, marginal product of third, and marginal product of fourth. That's how you go about it, friends. That's how you go about it, friends. Absolutely, sir. Again. If you talk about average product, friends, what is average product equal to? Average product at any level is equal to total product divided by labor, or total product equals to average product into labor. That is how you go about it, friends. I hope it's crystal clear, friends. Yes, sir, clear. Yes, sir, clear. So let's go to the institute's material and see what new MCQs we can solve from there. Okay, please copy this down until, and if done, please write done in the chat so that I can remove this and go to the particular PDF. Okay, got it. So this is our institute material. See, it has both the questions from production and cost. But as you know, we have only done production so far. That is unit 1 has been completed. So we will solve only questions related to unit 1. Once we complete cost portion, in our next class or the class beyond, we will complete cost as well. So no harm done. All right. Let's have a look here. Let's have a look here. See, the question is, which one of the following is considered, pay attention friends, which one of the following is considered production in economics? What say guys? Tilling of soil, singing a song before friends, preventing a child from falling into a manhole on the road, or painting a picture for pleasure? What do you say? See, production implies creating something kind of utility and something of value. It's only done in case 1, when you are tilling the soil. So that is production. Some kind of service is being rendered here. Absolutely. So A. Again, question number 2. Identify the correct statement. Average product is at its maximum when MP equals to AP. Law of returns to scale relates to effect of change in factor proportions. No, because increasing returns to scale is related to long run, not factor proportion. Economies of scale arises only because of individuals of factor proportion. Sir, what is economies of scale? Don't worry, I will explain now. And internal economies of scale can accrue when industry expands beyond optimum. No. So the answer is average product is maximum. You all remember it was MP and AP came and met MP here. So AP was at its max. AP is maximum when AP equals to MP. Remember, AP is maximum when AP is equal to MP. Please remember this, friends. AP is maximum when AP equals to MP. As far as economies of scale is concerned, that I will explain right now. Nothing to worry there about. Okay, so now let's understand what this economies of scale exactly represents or is. Okay, here we come. See. See, my dear friends. There are two concepts here. Number one is economies of scale. Number two is diseconomies of scale. What are economies of scale? When you decided that you will undertake production activity on a large scale. I'll repeat my statement. When an organization, you means an organization, has decided that they will produce on a large scale, that is, there is some benefit. What is the benefit? That is, cost per unit will be very little. That's economies of scale. Sir, we did not understand. Let me ask you a simple question so that we can come on to the track. Okay? Let me ask you a simple question. Okay? Let me ask you the simple question. My question is, you all have, drunk that Coca-Cola bottle that comes of 60 rupees, right? Have seen that at least. It's a 1 liter bottle. Coca-Cola and Pepsi both have this 1 liter bottle for 60 rupees. Have you all seen it? Yes or no, please? Yes, sir, we have certainly seen it. Can you tell me how much does it cost Coca-Cola to make that bottle? I mean, along with the cold drink? All bottling cost and etc. included. How much total does it cost? Can you tell me? You will be surprised, but it takes only around 60 paisa for one bottle, along with the bottle cost. How is it possible? It is because Coca-Cola is manufacturing in humongous scale. So when you are doing work in humongous scale, per unit cost will be negligible, will be nothing. Per unit cost will be negligible. Okay, is that so, sir? Yes, that is so. Let me give you an example, you will understand. Okay, see. Mr. Harsh is a business person. Okay, Mr. Harsh is a business person. Now, Mr. Harsh has a godown which has the capacity to produce, or which has a factory which has a capacity to produce 10,000 chips per year. Sir, how many chips did you say? 10,000 chips per year. So Mr. Harsh is in a godown, is a producer of a product and can produce 10,000 chips per year. Okay. The godown rent is 50,000 per year. Now, Mr. Harsh finds that demand is too low. So Mr. Harsh is producing only 1,000 chips. Mr. Harsh is dealing with only 1,000 chips. Yes, sir. Only 1,000 chips Mr. Harsh is dealing with. So can you tell me what is the per unit cost? Now see, 50,000 per year and producing only 1,000 chips. So 50,000 by 1,000. So per packet chips production is 50 rupees. Per packet chips production is 50 rupees. But imagine a world where Mr. Harsh decided to produce 10,000 chips per year because the capacity is to produce 10,000 chips a year. Now when they decide to produce 10,000 chips, The per unit cost went down from 50 rupees to 5 rupees. 50,000 rent and 10,000 units. So per unit cost comes to about rupees 5 only. This is called the advantage or economies of scale. That is, when you produce more, your per unit cost falls so much your per unit cost falls that you are able to produce it in large quantities at a small in a small cost. Understood, sir? That advantage is called economies of scale. Acha, is that the thing? Yes, my dear friends. In cost, when we study cost, don't worry. When we study cost, we will talk about internal economies, external economies, internal diseconomies, external diseconomies. Don't worry, we have all that in the pipeline. Don't worry. We will do all those things as well. Okay? Yes, sir, we got it, sir. Understood. So now let's come back to the question. Let's come back to the question. Which of the following statement is true? Let's talk about this one. Number 5. In the production of wheat, all the following are variable factors that are used by the farmer except, come on, which one of them is not a variable factor? Which of them is a fixed factor? The question is trying to ask. The question is trying to ask which one of them is a fixed factor. If not a variable, then has to be fixed. Come on, friends, answer this. See, seeds and fertilizer is variable. Tractor is also variable, used everywhere. Number of hours can be varied, but the field, I have told you now, the land, the piece of land is fixed factor. And so here the fixed factor is field, because they are asking all the followings are variable factor except, means they are asking which one of them is a fixed factor. So field means the piece of land on which wheat is grown. And so this is the answer, the field, the land. Tractor is used elsewhere also, so we are not saying tractor. Yes. Yes, Aditya, absolutely. It's just that my focus is on next question, right? Moving on. Whenever there is diminishing marginal returns, what does it imply? Diminishing marginal returns imply what? That average variable cost will decline. Okay, forget this is from cost. So let's not do it right now. You all will be confused. Don't do it. Let me explain cost and then we will do it. Let me check. This is from production now. Right. So this one is correct. See, the marginal, average and total product encountered by a firm produced in the short run exhibit all the following relationship except, read all the 4 and tell me, guys, which relation is not true in the short run. They are talking about the short run. It is written here, short run. Which of the following relation is false in the short run? Not holding true. Come on. Come on, friends. See, when TP is rising, AN may either be rising or falling, correct? When MP is negative, TP and AP are falling, that's correct. When AP is at its maximum, MP equals to AP, correct? And TP is rising, absolutely correct. When MP at its maximum, wrong. When MP is at its maximum, AP is not equal to MP. So it's wrong. And our answer is option D. Option D will be our answer. Option D will be our answer. Yes, sir, we are able to understand this. Okay, next, good question. Number 11, we have studied production function. Okay, so the question is, which one of them is the best definition of production function? Best definition of production function. Come on. We have studied what production function is. I will give you a hint. Through this equation I taught you. or through this equation I taught you. Production function. Yes, sir, we remember. So see, the best definition of production function is that it is the relationship between inputs and quantity needed to produce output, because it's the relation between input and output after all. So why so much of drama needed? Simple definition, correct definition. Relation between input and output, plus full stop. Let's see what is written here. Okay, so 14 to 16, again, a numerical based question. It's interesting. See here, hours of labor. It's indirectly referring to variable factor. A question like this we did today only. A few minutes back we discussed. Okay, use the following information to answer 14 to 16. Come on, tell me. 14, 15, 16, each one. First of all, you take time, you read the question, you solve, and then we will discuss. Then I will solve one by one. Come on, mates. So see, when you hire one laborer, total output is 100 and MP is 100. When you hire two laborer, marginal product is 80. So it is increased by how much? It has increased by 80. So total output is 180. Now it is 240. So it must be 60. Let's see what they are asking. What is the total output when 2 units of labor are, 2 hours of labor are employed? So at 2, it will be 180. Done. What is the marginal productivity of third unit labor? Done. 60. Yeah. What is the average product of first 3 hours of labor? So now we have to find out the average product. Okay. So now total output is 240. So 240 divided by 3, because average product is total product by units of labor, that is units of variable factor. So total is 240, labor is 3. So 80, there you have it. 16. Is that clear, friends? Come on, everyone. Is that crystal clear? Yes, sir. It indeed is. Okay. Actually, I'm tracing the ones which are related to production only. Okay. Another good question. Which of the following statement is true? Question 43. Question 43. Which of the following is true? Man can create matter. Service of housewife are considered production. When a man creates a table, he creates matter. See, services of a doctor are considered production. Anything whose value can be calculated, will be considered as production. Services of a doctor has a fixed monetary value. Services of a housewife don't have fixed monetary value, market value, and hence not considered production. Yes, the service is valuable, but they are not. We cannot calculate that value, the number, and hence it's not considered production. Okay. Which of the following is the function of an entrepreneur? Which of the following is a function of entrepreneur? Come on. So see, the question is, which of the following is a function of an entrepreneur? Initiating a business enterprise, yes. Risk taking, yes. Innovation, yes. So all absolutely correct. All seems to be the correct answer. 45 is a good one. So 45th question is a very good one. Come on, answer me this one. In describing a given production technology, short run is best described as lasting. What is short run period? 6 months, 5 years, as long as all inputs are fixed, or as long as at least one input is fixed. When will you call a period as short run period in production? Come on. Yes. At least one input is fixed. See, short run and long run is not like accounts. Like in accounts, what happens? There is current assets up to 1 year, non-current assets beyond 1 year. That is the fund of accounts. That is the fund of accounts. Economics tells no. As long as any one input is fixed, bus, we are in the short run. If all inputs become variable, we are in the long run. That's the basic fund of things. Sir, it's crystal clear, I believe. There is no time period based division. Not all. Arey Baba, in short run also there are fixed and variable factors. Na? So why all will be fixed? At least one input is fixed. Okay, got it, sir. Right. Next is the question related to long run. If decreasing returns to scale are present, if decreasing returns to scale are present, then if output increase by 10%, if output increases by 10%, if input increases by 10%, what will happen to output? Exactly 10, more than 10, less than 10? What do you think? Come on. We discussed it today. You cannot make mistake. Very good. You are not making mistake. We discussed that in decreasing returns to scale, what happens? If input is increased by 10%, yes, output will increase. Arey Baba, if you are putting in more raw material, output will increase. But in decreasing to scale, it will increase by, let's say, lesser than 10%. Let's say 6%. And so the answer will be output will increase because inputs are increasing, but at a lesser rate, at a lesser pace, as you can see, at lesser than 10%. Lesser than 10%. Lesser than 10%. Okay, got it, sir. Got it, sir. Moving on, sir. Next, come to question number 48. If you talk about question number 48, tell me what is the answer. Take your time. Number 48. What do you think will be the answer? See, now see, if the marginal product is below average product, let's draw the diagram. You see, what did we draw? It's like this, and MP will go down now. Negative. Okay. As far as AP is concerned, for the first unit it will be same, and then it touches and it goes down here. Now, what is the question talking about? Question is telling us if MP is below AP. So see here, MP is below AP. What is happening to AP? AP is falling now when MP is below AP. So the answer will be AP will be falling. Yes or no, friends? So yes, AP will be falling. Got it, sir. Got it, sir. Got it, sir. Now let's move on. Now let's move on. The AP of a labor is maximized when MP of labor equals AP equals 0 is maximum idea, none of the above. What say, guys? See, you all discussed this. Again, the same diagram I am drawing. MP going up, coming down. AP going up, reaching maximum, and then falling down. So what do you think? What do you think has happened here? AP is maximum when MP meets AP. So when MP of labor equals AP of labor, at that time AP is maximum. At that time AP is maximum. We have done it a significant number of times. We have revised it a significant number of times. Isn't it, sir? Yes, sir. Now, another good question, very good question. Question number 50, if you see. The law of variable proportion is drawn under all the assumptions, except, so which one of them is not an assumption? Except means not an assumption. Except means not an assumption. Question 50, friends. Which of the following is not an assumption? Come on, let's hear it from you. What do you think is the correct answer? All right. Great. So my dear friends, if you talk about it, let's see. The law of variable proportion is drawn under all the assumptions mentioned below, except the assumption that, see, changing technology, pay attention friends, pay attention friends, pay attention friends. There must be some inputs when quantity is fixed. Yes, this is correct. We consider inputs are not economically profitable. Correct. The technology is given and stable. Yes. Changing is not an assumption. It's the opposite. Technology is stable, constant. The assumption is rather this. Constant technology is the assumption. Acha. Got it. Let's see. Again, production definition, production function definition. What say, friends? Which one do you think will be the correct answer? See, it is a relation between inputs and output bus. Always the best answer. Production function, input and output. Best relation between input and output. Technical relation between input and output. That is production function. Absolutely correct answer. 51. Yes. Now moving on. Which one of them does the law of production doesn't include? It's not written include. It's written doesn't include. Law of production doesn't include. Come on, friends. Which one of them does the law of production does not include? A, returns to scale, it is there. Diminishing returns of factor, it is there. Variable proportions, it is there. So it does not include the least cost combination logic. It doesn't include the least cost combination of factors logic. It doesn't include the least cost combination of factors logic. And so 52D is our answer. 52D is our answer. Next, 53. An isoquant shows what? What does an isoquant show? All combination of two inputs that can be produced using a given set of outputs fully and in the best possible way. All the alternative combination of two products among which a producer is indifferent because they yield the same profits. All the alternative combination of two input that yield the same total product, or both B and C. What say, guys? What do you think is the correct answer? Come on, friends. 53 is really a good one. Let's hear it. So see, an isoquant shows all the alternative combination of two inputs that yield the same product, same total product. So 53C, absolutely correct. that yields the same total product. Okay. The production process described below. Chart-based question. Let's see what they are asking exactly. 0 worker, 0 output. 1 worker output increased to 23. 2 workers 40, 350. This is total output, okay, total product. Why not plot marginal product? Isn't it? Let's do that, sir. Here it is 0. Now, total product is changing by 23. So here 23. Here it has increased by 17 units from 23 to 40. So 17. And here it has increased by 10 units. So 10. So the question is, what is it showing here? It's showing constant marginal product of labor, diminishing marginal product of labor, increasing returns to scale, or increasing marginal product of labor. Come on, let's see what your answer is. Absolutely. Absolutely. So, my dear friends, your answer is, you can see it's showing the diminishing relationship here. And so your answer is diminishing marginal product of labor. Diminishing marginal product of labor. Diminishing marginal product of labor. It's correct answer. Next question. Question 60. Come on, friends. Let's try it out. Question number 60. 60, everybody. Try it out, friends. A fixed input is defined as the input whose quantity can be quickly changed in the short run. Whose quantity can be quickly changed in the short run in response to the desire of the company to change its production. Option A. Option B. The input whose quantity cannot be quickly changed in short run in response to desire of the company. Those input whose quantity can be easily changed in response to desire to increase the or reduce the level. Those input whose demand can be easily changed in response to desire or to reduce the level of production. So come on, guys. Which one is the correct answer? Very easy question as a matter of fact. Absolutely. You cannot change in the short run. In the long run, the inputs can be changed. In the short run, fixed inputs cannot be changed. Cannot be changed. In the long run, everything can change. So all the inputs are variable in the long run. But in the short run, they are not. In the short run, not all are variable. Some are fixed, some are variable. Absolutely, sir. Let's move on to question 61 then. What is average product defined as? What is average product defined as? See, average product is total product by units of variable factor. So what is it? Total product divided by the number of units of variable input. That is the correct answer. This is average product. This is average. Okay. Okay. Number 64, friends. Come on, everyone. Number 64, everybody. Suppose the first 4 units of a variable input generate outputs of this. What is the marginal product of third unit of output? Third unit of input, my bad. Third unit of input. So see, what is marginal product of third unit? I told you marginal product, I have made you write the formula as well. If you check it, if you check your sheet, you will find out the formula that marginal product at any level is total product at that level minus total product at the previous level. So total product at 3 units level is 450. Total product at 2 units level is 350. So 450 minus 350 seems to be 100. And therefore your answer is 100. That's fantastic and correct. That's fantastic and correct. 450 minus 350 because they've asked for third unit. So for third unit, you take total product up to third unit and total product up to 2 unit and subtract them obviously. Okay. A good one, diagram based question. Let's see what they're asking. Use the following diagram to answer the question. The MP of the third labor is dash. The MP of dash labor is negative. So see, they're asking the third unit of labor marginal product they're asking. So see, a very good one, best question. See, total product of 2 units is how much? 14. And total product of 3 units is how much? 20. They're asking MP for third unit. So TP is 20 minus 14, 6. So the first question answer is 6. Okay. Now MP of dash labor is negative. Now see, once total product is maximum, beyond this MP is negative. So now here when TP falls, that is at 6th unit. When TP falls at 6th unit, TP falls. So MP will become negative. So answer will be here also 6. So 6 and 6. Very good question. 6 and 6 will be our answer. Yes, sir. Sir, how did you find this? I will tell you. MP of third unit means what? TP of 3 units minus TP of 2 units. So I just saw 3 units is corresponding to 20. 2 units is corresponding to 14. So 20 minus 14, we got 6. Plus, that's it. That's what I did. Acha. And when TP falls, MP becomes negative. So when did TP fall? At 6 units. So MP became negative at this unit. In the third of the 3 stages of production, MP has a positive slope. No. MP lies completely below AP. Maybe. Yes. TP increases. No. MP is positive. No. So B is correct. MP lies below AP. MP lies below AP. That's correct. That's correct. Next, 76. A very good question. The most important function of an entrepreneur is to earn profits, to finance, to innovate, or bear the sense of responsibility. Yes, the main function is to innovate. Okay. I have another question. Come on, you all tell me this. My question is, the point at which TP curve changes its slope from increasing rate to diminishing rate in short run. Obviously, in short run only you have increasing rate and diminishing rate. What is the point called? The point at which this happens. What is that point called, friends? I need to know the answer from each one of you. The point at which TP curve changes its slope from increasing rate to decreasing rate in the short run. What point do you think it will be? What point do you think it will be? Absolutely. Absolutely correct. So if we have a discussion, my dear friends, the point at which TP curve changes its slope from increasing rate to diminishing rate in the short run, that point is known as the inflection point. Absolutely, inflection point. Inflection point. And what is maximum at inflection point? What is maximum at inflection point? What is maximum at inflection point? Come on, answer me this as well. What is maximum at inflection point? Answer me. What is maximum at inflection point? Absolutely. MP. Sir, MP. Marginal product is maximum at inflection point. That's the absolutely correct answer. Marginal product is maximum at inflection point. Absolutely correct answer. And if you want to look at the point, I'll show it to you. It looks somewhat like this. You see, the total product is like this and then this. So the curve is changing place. The change is taking place here. The point at which this change is taking place is the inflection point. Is the inflection point. If you see the MP curve, it will become a maximum here. Then when TP is maximum, MP will become 0. And when TP falls, MP is negative. So this is the same point. So at inflection point, TP is changing its slope and MP is, yes, absolutely. So my dear friends, there it is. I hope it's crystal clear. My dear friends, this brings us to the end of production unit. I mean, chapter of theory of production and cost. The unit of production is finally over. Next day, we go ahead with cost. Please revise production because all the things between production and cost are very related to each other. So production and cost, I repeat, are very strongly related to one another. So I'll request each one of you to make sure before you attend the cost class, you revise the entire production because cost is directly related to production. Okay. So with that being said, I wind up the day. Thank you very much. Bye bye for the day. Tata.